In this video, we discuss about motion in vertical circle. When studying the motion of a body in a vertical circle, we have to consider the effect of gravity. Due to the influence of Earth's gravitational field, the magnitude of velocity of the body and tension in the string change continuously. It is maximum at the point L and it is the minimum at the point H. This is the lowest point and here is the highest point and here is the middle point. As it is going up, the velocity and the tension decreases, and when it comes down, velocity and the tension increases and it is the maximum at the point lower point L. Now consider a small body of mass m attached to one end of a string. Here, this one end of the string. So the component weight is acting exactly downwards and it needs the centripetal force acting towards the center. Here when it is reached the middle point, the centripetal force is acting towards the center. So every time the centripetal force acts towards the center, so here the tension we can take T1, here tension T2 we can take, and the tension T3 we can take a point P. We assume the point P of a body reach this point and it has the tension T3. So we are going to derive the velocity of a body at any point P. At this point, the weight is acting downwards, mg, and it has the two components, horizontal and vertical component. So this is a horizontal component, mg cos theta, because this is an angle from the vertical. So from the vertical, here is the angle. So this is the horizontal component, mg cos theta, and here is the vertical component, mg sin theta. And the velocity of the body at the point P is v. So we are going to derive an expression for velocity. To derive the velocity expression, we need the knowledge of conservation of energy. Conservation of energy. Energy at any point is conserved, which means at the point lower level, it has the highest speed, the maximum speed, so it should have the maximum kinetic energy. Using this kinetic energy, the body is moving upwards. As it is going upwards, the kinetic energy is being reduced and the potential energy is increased. So at the point P, it has both kinetic and potential energy. At the point L, it has only the kinetic energy. But when we add kinetic and potential energy at the point P is equal to kinetic energy at the point L, that is the conservation of energy. So we can write energy at P is equal to the total energy at the point L. So here we have the kinetic energy plus potential energy. Here we have kinetic energy. This addition of these two energy is equal to the total energy. So what is the kinetic energy formula? Half m. The velocity of the body at the point P is v. So v square. So potential energy is mgh. The h is from the lower point. From the lower point, the point P is h above the ground. H meter above the, not ground, above the lower point. So here mgh. The kinetic energy is half mu square because the initial speed, we assume this is the initial speed here, the highest speed, initial speed, half mv square. Now I want to multiply the complete formula by 2. So I multiply 2 here and here 2 and here 2. So here these 2 cancel, here 2 cancel. So finally the formula is mv square plus 2 mgh is equal to mu square. Then here the mass factor is constant, so I can cancel here. Then the formula will be like this: v square plus 2gh is equal to u square. Here I want to find v square, so v square is equal to u square minus 2gh. So when you remove the square, here will be the square root u square minus 2gh. So this is the expression for the velocity of a body at any point, square root of u square minus 2gh. Then in the next video, we are going to discuss about how to find the tension at the lower point, at the middle point, and at the highest point. So first we will be deriving the expression, a common expression for the tension. Then later we substitute the height value in the formula and we find three cases for the tension at the point L, at the point M, and at the point H. So I hope you will be watching the next video to learn how to find the expression for the tension. Thank you very much.